It's most certainly the biggest planet of all time. NASA specialists have simply reported that this planet is, as a matter of fact, incomprehensible. Yet it truly exists. B Centauri b is genuine, and it's beyond anything we imagined in space science. With the disclosure of this yet again monster, we are confronted with the unavoidable issue of what is truly conceivable in this universe. It appears as though the universe is continually facing us with outrageous revelations, new exemplifications, and unsolvable riddles. B Centauri b not only explodes everything that has gone before concerning size, this amazing planet also orbits two of the most insane and deadliest stars in the known universe. Jupiter is by a long shot the biggest planet in our nearby planet group, more than multiple times our little Earth would fit inside the gas monster. Now, imagine that B Centauri b is in excess of multiple times the size of our Jupiter. This planet is not just the biggest we've ever found. It is also the most monstrous, as it orbits two incredibly hot B-type stars, which are among the most gigantic and brightest stars in the universe. The climate around these stars is quite unfriendly due to strong radiation and extreme temperatures, making the presence of this giant planet a genuine wonder. B Centauri b was found by a global team of cosmologists chasing after exoplanets with the European Southern Observatory's extremely large telescope in the Chilean Atacama Desert. The extremely large telescope is arguably one of the most advanced optical telescopes on the planet and enables observations of far-off planets invisible in infrared light. Thanks to this technology, we can find small objects, such as exoplanets, in the vastness of the universe with excellent clarity and detail. The discovery of B Centauri b was first reported in December 2021. The disclosure was not just a genuine shock in terms of the size of the planet, but also a significant leap forward in the investigation of exoplanets that exist in different star systems. We only have one star in our solar system, so the planets orbit around a center in a specific order. In various star systems, there are 2, 3, or even 4 stars that circle one another, and their planets orbit the central star to which they belong. You can well imagine that this leads to fascinating celestial bodies, and that there is more confusion in such systems, with planets exposed to more extreme cosmic impacts. It looks like B Centauri b is the only exoplanet in its star system, and that is not actually amazing because the climate of the stars isn't exactly welcoming. How should the planet form? The intriguing question surrounding this surprising exoplanet is how it was able to form in such a harsh environment. Planets are typically preceded by a star, or in this case of a double star system, by 2 stars. According to current astronomers, stars are formed from the combining gas clouds. Remnants of gas and dust remain around the young stars as rotating disks in which planets can then form. However, in very hot stars such as B Centauri, the radiation from the stars typically annihilates the remaining disk rapidly, preventing planet formation. So why was B Centauri different? It is theorized that within the gas cloud in which the B Centauri system formed, there was probably an extra thick area that somehow endured the extreme radiation of the young stars. It was in this extraordinary region that the only and massive exoplanet in the system formed. Specialists further explain the formation of B Centauri b as an immediate remnant of a disturbance that resembles an emotional and violent event. In this process, the protoplanetary disk circling the star cools and is gravitationally separated into at least one planet-sized part. Rather than steadily developing from a small core that accumulates matter and gas, the planet forms here basically in a rapid cycle under extreme conditions. This kind of planet formation stands out from the more traditional model of core gradual accumulation, in which planets evolve from the bottom up by gathering increasingly more material from their surroundings. This instability offers another alternative explanation of how enormous gas giants, such as B Centauri b, can form in a system that is generally considered completely inhospitable for planet development due to the intense radiation and massive gravitational forces of the nearby stars. There seems to be nothing impossible in our universe, and we can marvel at the ways in which the universe finds to create peculiar objects, colossal planets, and different interests. In light of these momentous discoveries, Astronomers have had to admit that for a long time, they had a very limited view of how planets form and how they don't form based on our own solar system. Our universe truly appears to keep guiding our researchers and making them pleasantly realize that despite their intense studies, they are still only beginning to uncover what really lies in the vastness of the universe. You might know about the Centauri framework from something else entirely. Setting Alpha Centauri, our closest star framework, is simply 4.3 light-years away. 3 stars circle around a typical center. That's what scientists believed in the relatively recent past. Alpha Centauri was a solitary star until better telescopes showed that it was a double star. A little later, a third star was found, the star Proxima Centauri. Together, this triple framework shapes our closest grandiose area, and we have currently found a few exoplanets there excessively. One of them might actually look like our Earth. The Beta Centauri framework is the second star framework found in the star grouping of Centaurus. Notwithstanding the similitude in name and closeness in the same star grouping locale, Beta Centauri and Alpha Centauri are not associated. Beta Centauri addresses a substantially more distant and undeniably more enormous double star framework. The similitude of the names is consequently simply because of their position in the equivalent heavenly body district. You should likewise not mistake Beta Centauri for Beta Centauri. This star, additionally formerly known as Hadar or Ina, is another unmistakable diverse star framework in the Centaurus and around 390 light-years from Earth. Beta Centauri is one of the most splendid stars in the night sky, and space science buffs know it as part of the Southern Cross. How about we return to Beta Centauri and its striking pairs of incredibly hot B-type stars? These stars are known for their high mass and extraordinary radiation. Because of outrageous discharges of ultraviolet and X-rays, B-type stars are among the most monstrous and brilliant stars in the universe, which normally makes them especially fascinating objects for stargazers to concentrate on. Truth be told, the atmosphere around the pairs of stars of Beta Centauri is so outrageous that there ought to be no planets there. The extraordinary radiation from these stars is frequently viewed as so forceful and harming to the development of planetary atmospheres that the presence of the exoplanet Beta Centauri B is genuinely fabulous. We have proactively taken a gander at how Beta Centauri B might have shaped under outrageous conditions. Researchers trust that this planet can endure in light of the fact that it now circles far external the focal point of the star. The distance among it and its focal stars is on normal multiple times more noteworthy than the distance between Jupiter and the Sun. The broad circle clearly safeguards the planet from the extreme radiation, universes of limits, exoplanets of exemplifications. Beta Centauri B is consequently a genuine characteristic. However, we are still far from knowing whether it truly is the biggest exoplanet in the universe. Up until this point, we are aware of a little more than 5,000 exoplanets, which is probably a little rate contrasted to the real number of planets in the known universe. In spite of the fact that we as of now know a little number of these universes at the second, we have proactively seen so many incredibly wild planets that the universe can creep us out. Space is loaded with wonder, tone, and excellence, but it's likewise home to limits and places so dangerous we can scarcely envision. HD 189733b is one such up-and-comer. This far-off world is known, among other things, for its superclimate conditions, which brings storms with rates of more than 7,000 kilometers per hour. However, that's not all that's truly cool about this planet. The downpour made of liquid gas, which is made by the very high temperatures and quick breezes in the climate, is startling. Its dark blue variety, brought about by the dissipated silicate in the air, makes HD 189733 be outwardly alluring and extraordinary. Yet, we should be straightforward. Nobody would need to stop here while traveling through the universe. When it comes to outrageous worlds, Kepler-10c is a must. Scientists facetiously call this exoplanet the Godzilla of the worlds, with a diameter practically that of Earth and a mass that could actually depend on multiple times more prominent. Kepler-10c totally turns our thoughts of rocky universes on their head. Its density shows that it is generally rocky, which makes it a mystery as this mass too pushes the limits of what we know about planet development. WASP-12b is another momentous applicant among the limit exoplanets. It circles so close to its star that this Jupiter-like planet is as hot as a bubbling hellfire. A year on hot Jupiter endures not exactly one Earth day. We have the distinct inverse with OGLE 2005 BLG 390lb, which is one of the coldest known rocky planets in the universe. With temperatures on the whole planet so far beneath freezing that nothing and no one could live there, it circles in isolation. Scientists are as of now uncertain whether OGLE 2005 BLG 390lb was truly brought into the world in the critical progression of star arrangement in the equivalent framework, or whether the frosty, desolate planet was caught by the star sooner or later as a drifter planet bound to it. One planet that explodes is J1407b, otherwise called Super Saturn. This exoplanet has a ring framework that makes our Saturn look pale. Suppose we, as it were, move the rings of this exoplanet to our planetary group. We could undoubtedly see them with our own eyes from Earth. Anyway, the attractive energy pole of the planet with its outrageous rings is so extraordinary that we would prefer not to be in its direct area. It's one more marvel of our universe. These disclosures are further breathtaking instances of the fantastic magnificence and outrageous variety in our universe. Click the subscribe button now and be part of each new video.